Alright, what we're going to do now is we're going to look at the Oxy Acetylene. I have this angle, you guys can come over that way if you want to see it, because I'm trying to keep it within here so that we can see it, and then you can go back over it on YouTube and don't get the camera. Now, what we have is the oxygen, what is called the oxygen R, and an acetylene MC, and you guys will be doing more labs on this stuff. We have labs on why it's called MC, how many cubic feet, and how many cubic feet of oxygen is in there. They used to call it MC because the motorcycle lights used to be powered off of acetylene. Acetylene is a very dangerous gas. Acetylene, acetylene, 3% acetylene to 80% acetylene mixed with air, and it can blow up. So acetylene is very dangerous. Acetylene can blow up if you put more than 3 cubic feet together, it gets excited. So this bottle has in it acetone also. It has acetone and acetylene, and then it has a dimetone, or a synthetic coral-like thing where the acetylene is absorbed. It takes like 8 hours to fill a B tank. So it takes a while, and so acetylene is a very dangerous gas, put it that way. So, my bottle, I have this wrench, the 1/4 inch bottle wrench is on the back. We normally keep it on the bottle for you so that you can quickly turn it off if you need to. So I'm going to turn that on. And the regulators, always check your regulators to make sure these aren't turned the whole way out. They shouldn't be turned the whole way out, but they shouldn't be turned the whole way in either. We want these regulators unloaded when we turn this bottle on. We do not want it loaded. A loaded regulator can be very dangerous. A loaded regulator is when the person who did it before doesn't back it out and relieve the pressure off. So when you turn it on, it's already set for the pressure. What you'll hear is a squealing noise. That can be dangerous because oxygen, especially oxygen, if there's dirt in there, and you have high pressure oxygen going through a small orifice, and create heat and actually explode. All right, it doesn't happen, a lot of times, but it could happen. And the only people who really know about it are the people who do the insurance claims on the regulators for the companies like tourch and that. They go around throughout the country, and if they have a problem, they just pay the money because you can't. They're very safe, but then again, it's your fault for having a loaded regulator. So my point is, always unload the regulators. They shouldn't be back the whole way out. They shouldn't be loaded up with pressure. All right, so we're going to start with them unloaded. Also be careful, these pins are not the whole way out. You get 3,000 pounds of oxygen on the backside of this T-pin, and it's back the whole way out. It could actually fly off and shoot, hit somebody. So we make sure that they're not back the whole way out. We make sure they're not tightened the whole way in or loaded. Okay? There is about, an oxygen bottle could have around 1,500 pounds plus in it. So there's a lot of pressure in the oxygen. So these things can, even a regulator with the T can sometimes get stripped out. And if it gets stripped out, it'll pop out. So never have them pointing to you. Never turn these tanks on pointing at you. So right now, it's pointing in that direction. So when I turn this oxygen on, you really don't want to be in that position. Not to say it's going to happen, but it could happen. Okay? So now the acetylene doesn't have a lot of pressure. Acetylene we don't want to keep highly pressured. Bad things can happen if we have high pressure on the acetylene. So I'm going to open my acetylene up, and it's giving me about a quarter of a tank on the acetylene. Alright, so I'm opening my tank about a quarter of a turn. The valves are both closed. My tank reads a quarter of a tank on the needle. Right here it reads a quarter. Now this one here is going to tell me what I'm set for on my regulator. But what I'm going to do is I'm going to open my valve on my gauges, and then I'm going to turn my T-handle in, and I'm going to set for about 5 pounds roughly. And that's pretty much determined on what kind of heat I want, what kind of tip I'm using. The tip I'm using, it's rated at a 4. 5 pounds is going to be good enough for what I'm going to do for this particular tip. So there's different ratings on here, but this tip here for what we're going to be soldering. Now you can see when I turn this off, I set it for 5 pounds. It went up to 7 pounds. Okay. So you want to set your pressure with the valve open. When I closed it, it went up. That's why I set the pressure with it open. Now I'm going to work on the oxygen. So you want to make sure it's not pointing to you. And I'm going to turn that on. And this tank is saying it has about 600 pounds of pressure. So the tank has 600 pounds. And I'm going to open the oxygen. and I'm going to turn this in till I get around 10 pounds. So I'm doing a generic 10-5 setup for what I'm working on. Then I turn it off. This is going to go up. Now my pressure is set and I'm ready to go. Okay. Now I'm going to show you lighting, how to light and what kind of flame we're going to be looking for. What are the three types of flames? No, we have the three types of flames are going to be carbonizing, neutral, and oxidizing. We want to use either a carbonizing or neutral, which means we don't want a real intense hiss out of the oxygen. What am I going to light first, the oxygen or the fuel? The fuel. The fuel should be lit first. A lot of people don't like to do that because they get the little stringies, but you should be lighting the fuel first for safety and other reasons. So my fuel was lit first. I bring out my fuel. Then the next I'm going to bring up my oxygen slowly. And you can see how when I bring up the oxygen it starts to turn blue and get more efficient. And that right there is a pretty efficient flame for what we're going to be doing. We're going to be doing dissimilar metals. And we're going to be doing a solder, which is about 1200 degrees, and a hard solder flux, which we're going to talk about next. But that would be somewhat of a neutral carbonizing flame category. This will be more oxidizing, right? That's more of a neutral or a carbonizing to neutral, okay? When I shut it off, what am I going to shut off? I shut my oxygen off first, and then I shut off my fuel. Okay, so I set my oxidizer off first, then my fuel. You can see we have a little leakage out of that, which we don't want. It's not good. Now, after it's shut off, I'm going to show you how to unload my regulators. So what I'm going to do to unload my regulators is I'm going to open my acetylene and back out my T-handle till it goes to 0. So I backed out my T-handle, my gauge is at 0 now, and then I close off my acetylene. I'm going to do the same with my oxygen. I open up the oxygen and I back out my oxygen till it goes to 0. Now I turn that off, it's unloaded. And now I shut my tanks off. Shut that tank off, and I'm going to shut off my acetylene tank. And you should only keep it about a quarter of a turn on the acetylene so you can quickly shut it off. And what we've done now is I showed you how to set up our torch, how to load them up, how to light the flame to a carbonizing neutral flame, then how to shut it off, and how to unload my regulators and then turn off the gas. That's the way these need to be brought back. Okay.